Hello and welcome. This is a new episode from Aero Arduino, and this episode is about how to create a frequency counter using Arduino and a simple LCD. So, if you didn't yet subscribe to our channel, please subscribe to get our latest videos and visit us at our website aeroarduino.com. Let's get started and see this simple circuit that can measure up to 7 kilohertz signals using simple code and simple circuit. We are going to see more circuits using advanced code. Let's get started with this circuit here. As we've seen in other videos, how to connect Arduino to this type of LCD using 4 pins of data like this. Data connected to 4 pins on Arduino and enable pin connected to pin number 11 and RS connected to pin number 12, then read write connected to ground and VNode connected to ground, and the ground of the LCD connected to ground on Arduino, and VCC on the LCD connected to 5 volts on Arduino. Here is the backlight LED, the LED anode connected to VCC, and the cathode of the LED connected to ground through a resistor. Now let's see the code. Here we start by including the LCD library, then define the LCD. Those are the variables of this connection. And here are the variables we use to measure the frequency. Then we start by initializing the LCD and we get the input on pin A1 in Arduino, and then we measure the frequency and then display it on the LCD. That's a simple code. Let's start the simulation. Here we connect a frequency generator to pin A1 at Arduino to see the input. We can control the input frequency using this panel. Let's start the simulation. Here is 1 kilohertz output connected to Arduino, connected to pin A1, and here Arduino reads 1 kilohertz with small error. Then we start by changing the frequency. Let's make it 300. It has changed here and changed on Arduino as measured. Then we increase the frequency at 2.2 kilohertz, and it's also measured on Arduino. Let's increase it a little bit, 5.5. It's updating real time with also little error. Let's make it 6.3 kilohertz. We see that it's updating real time with error that is increasing as we approach a 7 kilohertz. Let's try 7 kilohertz. Here is the measured frequency with also some error in reading. But if we increase it above 7 kilohertz, it reads different values and the error increases. That was a simple circuit with simple code for Arduino as a frequency counter. I'll leave the link to the Tinkercad simulation and the code in the video description. So if you like this video, please like, share, and subscribe. Visit us at aeroarduino.com. Thank you and goodbye.